Hello friends, welcome to my another video. Today I'm going to discuss a very important topic here for the researchers who are dealing with semiconductor nanomaterials. They are eager to know about the band gap of the synthesized material. So, in most of the cases, we are using the Tauc method for determining the band gap of a semiconductor. In 1966, in around 1966, Tauc proposed a method of determining the band gap of a semiconductor around 1966. In 1966, Tauc proposed a method estimating the band gap of energy of a amorphous semiconductor using the optical absorption spectrum. Generally, Tauc method is based on the assumption that the energy depends on the absorption coefficient and can be expressed by the following equation, like alpha h nu to the power 1 by gamma is equal to simply E h nu minus of Eg, and bracket is from here. Here alpha is the linear absorption coefficient, H is the Planck constant, nu you know the frequency, B is a constant here, h nu again the energy, and Eg is the band gap, and gamma is equal to 2 or half depending on the electron transport properties of the synthesized semiconductor. If it is direct band gap semiconductor, then it will gamma is equal to 1 by 2, that is half. And for indirect band gap semiconductor, gamma is 2. Now, uh, alpha, which is very important parameter here, is the linear absorption coefficient, can be determined using the UV-Vis absorption spectra. That is, alpha is simply 2.303 into A divided by L, where A is absorbance. Absorbance you can measure using the UV-Vis absorption spectrometer, where you determine the absorption of a material against lambda. So L is the path length. Generally, we use the 1 centimeter QVT. So you just determine the absorbance and multiply it with 2.303. Then you can get alpha here. Okay, and as absorption is determined against lambda, so you need to convert the lambda in terms of energy, that is h nu, and h nu is simply hc by lambda. Okay, and h is 6.625 as you know, and 10 to the power minus of 34, and c is simply 3 into 10 to the power 8 divided by lambda, and lambda generally determined in nanometers, so 10 to the power minus 9. So it comes about something 19.8 if you just calculate it, and 19.8 into 10 to the power minus of 17 divided by lambda. So it is in joule. So you need to convert it in EV, because most of the cases, the for semiconductor nanomaterial, the band gap energy is generally in sort of a few EV. So in that case, you just divide it with 1.16 to the power minus of 19. So you just it comes about like this, zero point 0.5 divided by lambda EV. Okay, 1237.5 divided by lambda. So in Excel, you can means generally in absorption spectrometer we get the absorbance versus lambda. Okay, so these are the different datas. Means if it is in 1 nanometer spectral resolution, then the difference between two data point is about 1 nanometer. So for each lambda, you will get the absorbance, and similarly you will get alpha. You just multiply alpha with h nu and take the square. Okay, so you just plot alpha h nu here, whole square here along y-axis, and then h nu is along x-axis. Say for TiO2, you take the gamma is equal to 1 by 2, so it comes about alpha h nu to the power 2, and the plot is looking like something like this. Okay, so for the linear portion of the graph, you just draw a tangent, and this tangent cuts at a certain point along x-axis. For that point, this equation alpha h nu whole square is 0. As it is 0, so we will get a b h nu minus of eg equal to 0. Okay. So b is not equal to 0, so you will get eg is h nu. So band gap energy can be calculated using this plot. Okay, this is a very simple method, and you can just approximate. You will get the approximate value of eg. It is need to be correct for the different cases. So I just advise you to go through the literature before you just use your data of band gap energy, because in most of the cases, if you dope it or you synthesize in a different manner, you will get some variation of the band gap energy. So it needs to be corrected, means this equation need to be corrected. So I will propose that before use this data in a research paper or somewhere else, you must know the some variation of this equation or some correction of this equation. Thank you for your question, and please subscribe me and encourage me to do the different video on different research topics. Thank you for your patience.